Hey everyone, welcome back to another session of our CISSP study group. I'm B-Dubs and I'm pumped to dive into these topics with you. Whether you're grinding to pass the CISSP exam or you just love nerding out over cybersecurity, you're in the right spot. I really appreciate your dedication and it's awesome to see you all here. I'm thrilled to be on this journey with you. Last time, we continued Domain 5, specifically Objectives 5.3 and 5.4. If you missed it, no sweat. I've got a playlist ready for you to catch up. I'll drop the link in chat now so you can watch it later at your own pace. Now let's get straight to it. Today we're wrapping up Domain 5 with Exam Objectives 5.5, Managing the Identity and Access Provisioning Lifecycle, and 5.6, Implementing Authentication Systems. If you've ever wondered how organizations track who has access to what, this lesson is perfect for you. Think of IAM as the bouncer at an exclusive club. Only authorized people get past that velvet rope, and only with specific permissions. So grab your monster, get comfy, and let's dive right in. First up, let's talk about the identity lifecycle. The journey and identity, like a user account, takes from creation to retirement. There's 3 main stages in this continuous cycle: provisioning, review, and revocation. Let's break them down. Provisioning is where it all begins. When a new employee joins the company, they need access to systems, email, and maybe a key card for the building. But provisioning isn't just about handing out access. It's about doing it securely. This means running background checks, verifying identities, or making sure they are who they say they are, and assigning the right role-based permissions. Different roles need different types of access. For example, sales representatives need access to customer relationship management tools and sales platforms to track leads, manage customer data, and close deals. Developers need access to code repositories and testing environments to write, test, and deploy code securely. HR managers need access to sensitive systems like personnel databases and payroll systems. Access that needs especially careful management due to the confidential nature of the data. Now, just because someone has access today doesn't mean they should have it forever. That's where access reviews come in. Think of this as a regular checkup for permissions. Are they still supposed to have access to that sensitive database? Did their role change? Reviews help prevent privilege creep, which is when someone's access slowly builds up over time, like junk collecting in your garage. You've got to clean it out regularly before it becomes overwhelming. Regular reviews are important for maintaining security and compliance, especially in dynamic environments where roles and responsibilities frequently change. Access reviews should also occur during significant events, like role changes, to ensure appropriate access is granted and unnecessary permissions are removed promptly. Revocation or deprovisioning marks the end of the line, when accounts are disabled or deleted because they're no longer needed. Modern organizations use automated deprovisioning workflows to ensure immediate and consistent access removal. When someone leaves the company or changes roles, a critical automated process kicks in to protect the organization. Here's exactly what happens. First, the system automatically disables their accounts across all systems. Imagine instantly deactivating every digital key they possessed. Then, all certificates and security tokens are immediately revoked to prevent unauthorized access. The system carefully logs each action, creating a detailed audit trail. Finally, relevant stakeholders receive automatic notifications about these changes. This automation is important in today's organizations. It eliminates human error, it prevents forgotten accounts, and it ensures a consistent, thorough process every time. Now let's talk about vendors. These are external companies, like IT service providers or supply chain partners, who need access to your systems. They're not employees, so you need to be extra careful. Think of it like letting a contractor into your house. You want to make sure they only go where they're supposed to, and they don't wander into your bedroom. Managing vendor access requires special handling and critical safeguards. Here's the essential technical controls your organization needs. First, all vendor access tokens must have built-in expiration dates, like a hotel keycard that automatically stops working after you check out. Second, MFA is mandatory for all vendors, no exceptions. Even if they push back, MFA is non-negotiable when it comes to external system access. Finally, implement network segmentation to isolate vendor access from critical systems, like having separate entrances and restricted areas for contractors. They can only access exactly what they need and nothing more. Before granting any vendor access, you should follow these important steps. First, you should vet the vendor thoroughly. Don't just take their word about their security practices. Send detailed security questionnaires covering their controls, incident response procedures, and compliance certifications. Think of it as a security background check. Next, perform a risk assessment. Apply specific management frameworks for third-party relationships to understand the real risk they bring to your organization. Finally, you need legal documentation. Document all security requirements in legally binding contracts. No handshake agreements allowed. The importance of these controls is clear from past incidents. Take the 2013 Target breach. Attackers compromised an HVAC vendor's credentials, affecting 41 million customers and costing Target millions of dollars in settlements. Plus, regulations like GDPR and HIPAA have specific requirements for vendor access control. Remember, vendor access should be limited to only what's needed and reviewed regularly, with even more scrutiny than employee access due to the additional risk. Now, privilege escalation occurs when someone gains more access than they should have. This can happen in two ways, either by vertical escalation, which is gaining higher level privileges, like a regular user getting admin powers, or by horizontal escalation, which is accessing other accounts at the same privilege level. Think of vertical escalation like suddenly getting the master key to the whole building, while horizontal escalation is like getting keys to other apartments on your floor. Both are incredibly dangerous. Now, privilege escalation can happen either accidentally, like when someone changes roles but keeps their old permissions, or through malicious attacks. There's some common ways attackers will try to gain elevated privileges. They might try to exploit buffer overflows in poorly written code. This is when a program doesn't properly check input data size. They might target misconfigured file or directory permissions. Or they might take advantage of unpatched system vulnerabilities. So how do we protect against these threats? Organizations need several essential controls. Regular vulnerability scanning and patching serves as your first line of defense. Strict enforcement of the least privilege principle makes sure users only have access to what they absolutely need. Proper session management and timeouts protect active sessions from becoming targets. Well-configured access control lists, or ACLs, serve as your detailed security rulebook. For users with high-level access, like system admins, the best practice is to maintain 2 accounts. A regular one for your everyday tasks, like emails and meetings, and then a separate admin account for powerful actions, like configuring servers. On Linux, the sudo command allows temporary privilege elevation, like borrowing the master key for a minute instead of carrying it around all day. This way, if your regular account gets compromised, say by clicking a bad link or something, the attacker doesn't automatically gain admin access. It's important to audit the use of sudo and other privileged commands. By logging these actions, you can track who did what and when. This is important for security monitoring, detecting anomalies, and ensuring compliance with security policies. Now, service accounts are special accounts used by the system itself to run important background processes. Think of them as the maintenance crew of your IT infrastructure, working behind the scenes to keep everything running smoothly. Common examples include accounts for database management systems handling automatic operations, backup systems running nightly backups, and task automation systems executing scheduled jobs and workflows. When it comes to service accounts, we must be extremely careful with permissions. If a service account gets compromised, we don't want the attacker gaining access to our entire system. Here's the best practices that every organization should follow. First and foremost, follow the principle of least privilege. Give each service account only the exact permissions it needs to do its job, and nothing more. Implement regular password rotation schedules. And yes, even automated accounts need their credentials updated regularly. Whenever possible, use managed service accounts, which are specifically designed to handle automatic password management and provide enhanced security features. Configure these accounts so they can't be used for interactive login. This prevents attackers from directly accessing your systems. Finally, implement strict audit logging to track exactly what these service accounts are doing at all times. Now, documentation is important for managing these service accounts properly. You need 3 key pieces. The first is an up-to-date inventory, which is a detailed registry of every service account in your organization. Without this, you might lose track of accounts that could become security risks. Next, you need documentation of each account's business justification and permissions. If this isn't documented, then eventually you might end up with service accounts where nobody remembers why they even existed. That's a recipe for security problems. Finally, you need records of all dependency relationships between services. When making changes to one service, you need to know exactly what other services might be affected. For example, if a service needs to read from a database, you don't give it write access. Avoid using the same account for multiple services. That's like using one key for every lock in the building. If it gets stolen, you're in big trouble. Monitor service accounts for unusual activity since they're prime targets for attackers looking to exploit their privileges. Now, before we move on, let's review the crucial elements of identity lifecycle management. This is where all the pieces come together. Provisioning is where our journey begins. When a new employee joins, we create and configure their access permissions, ensuring they have exactly what they need for their role, no more and no less. Review serves as our regular security checkup. We don't just set it and forget it. We consistently audit permissions to make sure they remain appropriate as roles and responsibilities evolve. Revocation acts as our exit strategy. When someone leaves or changes roles, we need a clear and efficient process for removing or adjusting their access. Getting this wrong can create dangerous security gaps. Now, we covered 3 critical special cases in identity management. First is vendor access management. Think of vendors like contractors in your building. They need special badges and extra monitoring. We must be especially vigilant with external parties, implementing strict controls and continuous monitoring. Next, we covered privilege escalation prevention. This is important. It's like ensuring nobody can upgrade their regular key to a master key. We need robust security controls to prevent users from gaining unauthorized permissions. And finally is service account oversight. These automated accounts are like the building's automated systems. They often have powerful permissions to keep things running. Their elevated access requires particularly careful monitoring and management to prevent any misuse. Now that we understand how to manage identities through their lifecycle, let's shift gears to discuss a critical component that makes this all possible: authentication systems. After all, having a well-managed identity lifecycle is only effective if we can properly verify who users are in the first place. Today, we're going to explore several key authentication systems that are fundamental to modern security. First, we'll look at OIDC and OAuth, which work together to handle delegated access. You've probably used this when you click sign in with Google on various websites. Next, we'll explore SAML, the backbone of enterprise single sign-on. This lets you log in once to your company portal and access all your work applications seamlessly. We'll also dive into Kerberos, a powerful ticket-based authentication system. If you've ever logged into a Windows domain network, you've used Kerberos without even knowing it. Finally, we'll cover Radius and TACACS+, which are essential for network access security. These are the guardians that protect your VPN and remote access connections. Each of these systems has its own unique role in the security landscape, and understanding how they work is important for any security professional. Now let's see how each one operates. Now, authentication systems are the gatekeepers of your network. Think of them as security guards checking IDs at different entrances. We'll explore how these systems work in everyday scenarios. This table shows the most common use cases and where each system excels. OIDC and OAuth handles your social media logins. SAML enables employees to access multiple systems with only one login. Kerberos secures your Windows network, and Radius and TACACS Plus protect your remote connections. These technical terms might seem overwhelming at first, but don't worry, we'll examine each one in detail. Let's begin with the familiar example, the OAuth process you use when signing into an app with your Google account. We're looking at OIDC and OAuth, two powerful tools that work together to keep your online identity secure. Imagine you've just downloaded a new fitness app that wants to sync with your Google Calendar. This is a common scenario that illustrates how these systems work together. First, let's look at OAuth's role. OAuth is like having a valet key for your car. It gives limited access. When your fitness app wants to access your Google Calendar, it gets a special token. Think of it as that valet key. This token only lets the app see and update your calendar. It can't access your emails or your Google Drive. Those are completely off limits. Now, OIDC, or OpenID Connect, has a different but complementary job. While OAuth handles what the app can access, OIDC verifies who you are. It uses JSON Web Tokens, or JWTs, which are digital ID cards that tell the fitness app, yes, this is definitely their Google account. Now I want you to think of visiting an exclusive concert. OIDC acts like the security guard at the entrance, checking your ID to verify who you really are. OAuth is like the staff member giving out colored wristbands. Each color grants access to specific areas: general admission, VIP section, or backstage. Having a VIP wristband doesn't mean you can go backstage. It's all about controlling specific access levels. This powerful combination enables secure sign-on, letting you safely use your Google or Facebook accounts across multiple apps without sharing your password. Now, next up is SAML, or Security Assertion Markup Language. This one's a heavyweight in the enterprise world, especially for single sign-on, or SSO. SAML lets you log in once and get access to multiple systems without having to log in again. It's like having a universal key that opens all the doors you're allowed to enter. Now here's how it works. You log into your company's identity provider, or IDP, like Okta, Azure ID, or Ping Identity. Then, when you try and access a service provider, like Salesforce, Workday, or AWS, the service provider checks with the IDP to confirm your identity. If the IDP says you're good, you're in. There's no extra password needed. So how does SAML actually work? When you use SAML for authentication, there's three key pieces working together here. First, we have assertions. These are like digital ID cards. They carry important information about users, like, yes, this person is authenticated, or this user has admin privileges. Second is the protocol. This defines the rules of the game, how systems should ask for those assertions, and how they should receive them. It's like having a standardized procedure for checking IDs. Finally, we have binding. This is the secure delivery system. It ensures all these messages travel safely over HTTPS, like using an armored car to transport those digital ID cards. SAML uses XML to pass these assertions back and forth, and it's super secure, which is why it's a go-to in corporate settings. Now, Kerberos is another SSO system, but it's a bit older and it's often used in Windows environments, like Active Directory. It's named after the three-headed dog from Greek mythology, which is fitting because it involves three parties: the user, the service, and the Key Distribution Center, or KDC. Here's the basic flow. When you log in, you get a ticket granting ticket, or TGT, from the KDC. Think of this like getting a music festival's main entry wristband. This TGT is time sensitive and it expires after a set period for security. Then, when you want to access a specific service, you present your TGT to get a service ticket, or ST, like using your festival wristband to get specific stage passes. Each ST lets you access a particular service. Kerberos is great for internal networks because it's fast and secure, using symmetric encryption to protect the tickets. It's widely used in Windows domains for seamless authentication across multiple services. However, since it's complex to set up, it's mostly found in controlled environments like corporate networks. Now, I want you to think of Radius and TACACS Plus as two different types of security guard services for your network. They both protect your remote access points, but they work differently. Let's start with Radius, which is an acronym for Remote Authentication Dial-In User Service. This is the more common choice for remote access security, and it handles what we call the 3 A's of security: authentication, authorization, and accounting. First is authentication, where Radius verifies your identity, making sure you are who you claim to be. Next is authorization. Once Radius knows who you are, it determines what resources and services you're allowed to access. Finally, there's accounting. This is like an audit trail, keeping detailed logs of your network activity. Now, when you connect to a VPN, Radius is your security checkpoint, verifying your credentials and determining your access rights. While it's lightweight and widely supported, it has one limitation: it only encrypts your password and not the entire communication. Now for TACACS Plus, which is an acronym for Terminal Access Controller Access Control System Plus. Think of it as Cisco's premium version of Radius. Let me show you what makes it special. First, unlike Radius, TACACS Plus provides full encryption for all communication between you and the authentication server. This is a significant security advantage. Second, it offers more granular control by handling each AAA function. Remember, authentication, authorization, and accounting separately, letting you mix and match security methods. Finally, it excels at network device management, making it especially valuable for Cisco equipment since it was designed specifically for this purpose. Now here's an example. For a large corporate network with various remote access points, like VPNs and Wi-Fi, Radius might be perfect. It's simple and effective. But for managing sensitive Cisco equipment that needs detailed command authorization and logging, TACACS Plus would be the better choice. Both are excellent tools, and it's all about picking the right one for your needs. Now let's do a quick recap to lock this down. Think of Identity and Access Management, or IAM, like managing access to a secure building. For Objective 5.5, managing the Identity and Access Provisioning lifecycle, we covered 3 important stages. First was provisioning, like issuing an employee their first security badge. Then access reviews, where security regularly checks badge access levels. Finally, revocation, which was collecting that badge when someone leaves. We also covered special cases like vendor access, privilege escalation, and service account management. It's all about giving the right access to the right people at the right time and taking it away when it's no longer needed. For Objective 5.6, implementation of authentication systems, we covered how organizations verify identities with some everyday examples. First, OIDC and OAuth. Ever notice when you click sign in with Google on Spotify? That's these protocols in action. Behind the scenes, they let Spotify securely access just the parts of your Google account that it needs, without seeing your password. Next is SAML. This powers most corporate single sign-on systems. You log into your company portal once in the morning and boom, you have access to your email, HR systems, and cloud applications. No more endless password prompts. Then there's Kerberos, which you use every time you log into a Windows network. Type in your password once, and you're automatically authenticated to access network resources like printers and shared drives throughout the day. Finally, Radius and TACACS Plus are your VPN security guards. When you're working remotely and need to connect to the company network, these protocols make sure you're really who you claim to be. Now, why does all of this matter? Because poor IAM is like having a building with unlocked doors, missing security cameras, and no guest log. Hackers will walk right in. Good IAM, on the other hand, is like having a world-class security system where every entry point is monitored, every access is tracked, and every person only has the keys they absolutely need. Now that's all I've got today for Objectives 5.5 and 5.6. And now we've just finished Domain 5. You're absolutely killing it on the CISSP journey. Keep that momentum going. If you need to revisit anything, no worries. These recordings stay on YouTube and I'll add chapters after the stream so you can jump back to specific topics. Mastering this stuff is a massive step towards your CISSP goal, and these concepts will keep popping up, so tie them to real-world scenarios. Stay curious, keep practicing, you're doing awesome. Now who's ready for the after party? I'm heading right now to our Study GRC Discord server's CISSP voice channel. It's the perfect place for questions, insights, and connecting with the community. If you're not in the Discord yet, you can visit cissp.britwhite.io, and don't forget to grab your CISSP role when you join to get full access to our study channels. Our next session is coming up on Saturday, May 10th at 3 p.m. U.S. Central Time. We'll kick off Domain 6, diving into security assessment and testing. Thanks for watching, and I'll see you in Discord.